we're going to finish the second half of this section by doing some examples. Number 6 should be pretty straightforward. We want to find the first 6 terms, then the common difference, and then the nth term formula for the specific list of numbers. So if we look at this right here, it tells us the first term. But let's take a look at this. This is saying the term after the next term, that +1 means next term, is found by taking the term before it and adding 5. That's what this is saying. Take the term previous to this, add 5, that will give you the next one. So if we know that the first one is 6, the next one we will add 5, the third one we keep adding 5, the fourth one we add 5, the fifth one we add 5. So there's B. We already found really the common difference, which is 5, so D equals 5. And then for C, finding the formula, what you're going to do is you're going to do A sub n equals the first term plus n minus 1 times 5, which is the difference. So we plug that in. Again, we're going to distribute the 5. We're going to get 1 plus 5n. So A sub n can be calculated by doing 1 plus 5n. So now we come back to this idea of sum, and we talked again about this last section with the sigma notation. But we can go ahead and use this formula to make it a little bit easier. So that formula again is the sum of n integers is n over 2 times a sub 1 plus a sub n. So as long as we know the first, the last, and the number of terms, we are good. So we'll count the number of terms. There are 11. First term is 1, last term is 31, and we get 176. Okay. There's a problem like this in your web assignment where it says, the first 40 negative integers. So if you kind of think about what that is, it's -1, -2, -3, all the way to -40. If you look at that pattern, it's an arithmetic sequence. You keep subtracting 1. So this is our common difference, which is -1. But we're doing summation. So what we want to do is we're going to do the summation, which takes the number of terms, which would be 40, and we put it over 2, and we take the first and the last, so -1 plus -40, and we go ahead and calculate that. That's going to be 20 times -41, which gives us a sum of -820. And actually, I should have that notation cleaned up a little bit. We're finding the summation of the first 40 terms, so we put 40 down here. Same with this, this should be 11. Another summation problem. It gives us that formula that we just rewrote up there. So again, if we had the first and the last term and the number of terms, we should be able to just plug it in. So in this case, though, we have the first, we have the number of terms, which is n, but we don't have the nth term. So to find a sub n, we're going to do the first term plus n minus 1 times d. So this is a sub 1 again. This is going to be d. And the difference, common difference, we can see is we are adding 6. So 2 plus 6n minus 6. Our formula will be -4 plus 6n. So if I want to find the 25th term, I'm going to do -4 plus 6 times 25, and that should give us 146. So the 25th term is 146, so we'll use that in our summation of the first 25 terms. So it's going to be 25 over 2 times 2 plus 146, and that's going to give us 1,850 for the sum of those first 25 terms. This one's pretty straightforward. Go ahead, pause the video, put it in your calculator, and to get what the sum will be. We should get 16,100. So again, we look at the sigma notation, whereas before we would write out all those terms. Now, we don't want 200 terms. That would take way too long to do each one individually and add it. We can do a couple things though to help us with that formula, right? Because we need to know the first term and the last term. So if I take 1 and plug it in here, I get 4. And if I get 200 and plug it in, I get 203. So I'm going to take 4 plus 203. I know that I'm going to go for 200 terms, so 200 over 2. And I will get 20,700. And that will be the summation of those first 200 terms.